G'day method students. In this video we're going to have a look at equations of tangents and normals. So let's get stuck into it and first talk a bit about what tangents and normals actually are. So whenever you have a curve, and we know that we've been using differentiation to find the gradient at any point on a curve. So if you've got this curve here, which is in this example is a parabola, a tangent is a straight line that just touches the curve at a particular point, and at the point that it touches the curve, it has the same gradient as the curve. Okay, so a tangent will often just touch a curve and kind of not cross it anywhere else. Right, so that's an example of a tangent line. A normal is a line that intersects at the same point as the tangent, so it touches the curve at the same point as a tangent, but it has a perpendicular gradient to the tangent. Okay, so that means that the relationship between the gradient of a tangent and a normal, because they're perpendicular lines, the relationship is that the gradient of the normal is equal to -1 over the gradient of the tangent. And that will be useful, obviously, whenever we're trying to find the equation of a normal line. I guess the thing to point out here before we get into some examples is that tangents and normals are both straight lines. So they can both be written in the form y equals mx plus c. Right? And if we want to find out their equations, then what we're often looking for is a way of finding the value of m, the gradient, and also a way of finding the plus c. And that plus c usually comes from knowing a point on the line that we can sub in. So let's get stuck into the first example. We're asked to find the equation of the tangent to the curve y equals cos of x at the point x equals pi on 2. Okay, so let's start by seeing if we can find the gradient of the tangent, okay? Because we're being asked to find the equation of the tangent, which we know will be in the form, again, y equals mx plus c. So we're going to need to know how to get the gradient of the tangent. Now, at the point x equals pi on 2, well, if we want to know the gradient at that particular point, we're going to differentiate and sub in that value of x. So y equals cos of x dy dx. The derivative of cos x is negative sine x. And when x equals pi on 2, then dy dx, our gradient, is equal to negative sine of pi on 2. And sine of pi on 2, thinking about our unit circle, remembering that we read the values of sine from the y-axis, sine of pi on 2 is 1, so this will equal -1. In other words, the gradient of the tangent at this particular point is -1. Right, so that's our value of m. But we also need to find the plus c, right? Before we can say we've got the equation of the tangent line. And to do that, we need to have a point. Right, now at the moment we've got the x-coordinate of a point, right? Because we know that this graph has some point where x is equal to pi on 2. If we want to find the y value at that point, well, we're going to substitute it in again, but this time we're going to substitute it in to the original function. So we're going to say when x equals pi on 2, y equals, so we're subbing into the original function, and that'll be cos of pi on 2. And going back to our unit circle here, remembering that we read cosine from the x-axis, that value there is 0. So cos of pi on 2 is 0. And so that means that the graph goes through the point pi on 2, 0. And so now, well, we actually have all the pieces that we need to work out the equation of our tangent line. Right, we have our value of m over here, and we also have an x value and a y value that we know are on the tangent line that we can sub in to find our equation. So the final step is to say that if we think of our equation line as, our equation of the tangent line as y equals mx plus c, we're going to sub y equals 0, m equals -1, x equals pi on 2, plus c. So if we solve that equation for c, well, it's going to be 0 equals -pi on 2 plus c, and therefore c equals pi on 2. And that means that our equation of the tangent line is y equals -1 times x plus pi on 2. Right, and because we've got a fair bit of working there, let's make that nice and clear that that's our final answer. Okay, second example, this one's asking us to find the equation of the normal to the curve with equation y equals x cubed plus 2x squared at the point 1, 3. So this is nice. They've actually already given us the x coordinate and the y coordinate, which we will need to sub in towards the end of this process. But again, our first job is going to be to find the gradient of the normal. So for the gradient of the normal, again, we're going to use dy dx. And the derivative of x cubed is 3x squared. Derivative of 2x squared is 4x. And we're trying to find the gradient at the point where x equals 1. So when x equals 1, dy dx equals 3 plus 4. Right, now what that's saying is that the gradient of the tangent at this particular point when x equals 1 is 7. So we could actually say that this is mt, gradient of tangent, equals 7. This question is asking us to find the equation of the normal to the curve though. So the normal, remember, is -1 over mt, so it's -1 over 7. So that's the gradient that we're going to use. Now, to get the equation, again, we start with y equals mx plus c, and we're going to sub in our gradient as well as our x and y coordinate from the point that we know is on the line. And so we sub in y equals 3, m equals -1/7, x equals 1, and plus c, and now we're just solving this for c. So 3 equals -1/7 plus c, which means c will equal 3 plus 1/7. Well, 3 is really 21 over 7, so this would be 22 over 7 altogether. And so we've got our plus c, we'd worked out our gradient. We now know that the equation of the normal for this question is -1 over 7x plus 22 over 7. And again, we'll make that nice and clear that that's our final answer. So, a couple of quick examples there. One of the equation of a tangent, one the equation of the normal. You can kind of see the process there, right? We need to find the gradient first and then use a point that's on the line to work out the equation, remembering that tangent lines and normal lines are straight lines, so we can always try to find them in the form y equals mx plus c. Hope that was helpful.